Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to continue our discussion of Section 2 of Chapter 3, Function Notation. We're going to focus on figuring out the rule. So we're going to have our inputs and outputs, and we have to figure out, well, how did they get these outputs with that given input? So we're going to kind of work backwards from what we were doing last week. So let's take a look at some of the examples. Okay, so in your package you should find problem 3. It says write a linear function rule. We're going to go through 3 different practice problems. So number 1, the cost to make 4 bracelets is shown in the table. Write a linear function to determine the cost of any number of bracelets. So we have a table where in this table we are told how many bracelets have been sold and the cost of selling that many bracelets. So if we take a look, 1 bracelet costs $17, 2 bracelets cost $32, 3 bracelets cost $47, and 4 bracelets cost $62. So in order to figure out the rule, there's 2 pieces of information we need to know. We need to know your slope m, and we need to know your y-intercept b. So yes, this is related exactly to what we had done in Chapter 2, writing the equation of a line. Just now we're given a table form to write the equation from. So what we're going to need to do first is find the slope represented by the points in this table. So if we recall, slope is the change of y divided by your change of x. So what we're going to do, we're going to first figure out which one of these is representing your y value. So your y value is the value that you are measuring. We are measuring the cost of the bracelet, so that's going to be our y value. What we're selling, that's going to be our x value, the bracelets. So I want to first figure out my change in the y values. So I need to think through addition or subtraction, how am I getting from 17 to 32? Well, to get from 17 to 32, I would have to add 15. So this would be change of 15. And I'm not going to put plus 15. I'm just going to put 15 because I know that means positive. 32 to 47, I want to check it between all the numbers. 32 to 47, I would have to add 15 as well. And 47 to 62 would also be an adding 15. So every single time my change in y was 15. Now I'm going to divide that by my change in x. So my x is changed from 1 to 2, I added 1. From 2 to 3, I added 1. From 3 to 4, I added 1. So my change in x's would be 1, so I'm going to write over 1. And then I want to simplify that slope. So that slope, 15 over 1, m is 15. Okay, so that equals just 15. We don't need to leave it 15 over 1. That's not simplified. So once you know the slope, the change in y or the change in x, then you also need your y-intercept. So your y-intercept occurs when you have 0 as your x value. So you sold nothing in this case. So if we take a look, we need to figure out, well, what was the number at 0? So think about how we get from 1 to 0. You subtract 1, so that's the same change. The change was always 1s in the x's. We subtract 1. So we have to change that way with the cost. So since we're going backwards, I'm not going to add 15 to 17. That would tell me my amount for 2 bracelets. I need to subtract and find that when I sold 0 bracelets, $2 is where we were at for the cost. Okay, so what we have is we've got to now just put this all together. We have our b value, and we just need to make our equation. So if you recall our equation, y equals mx plus b. And all we're going to do is plug in m and b. So our final answer would be y equals m is 15, x+ 2. 2. So our equation of the line, y equals 15x plus 2. So if you take a look at our next example, we're going to write a linear function for the data in the table using function notation. Notice how this time it said we need to use function notation. So what we're going to do to write our equation, we need to find m, we need to find b. So again, if we recall, m is the change in our y values divided by the change in our x values. So we want to look at this table and we want to see how the y's are changing each time. So from 6.5 to 13, how could I get from 6.5 to 13 thinking of addition or subtraction? Well, we would add 6.5. So I'm just going to write 6.5. From 13 to 19.5, how would I get to that? Well, that would be adding another 6.5. From 19.5 to 26, you bet, another 6.5. So every single time our y values increased by 6.5. So we're going to write positive 6.5. I only put a negative, I was subtracting each time. I'm adding. The numbers were getting bigger. Now, as for my x values, how are they changing? From 1 to 2 is 1. 2 to 3 plus 1. 3 to 4 plus 1. So over 1. So my slope m of this line, simplify that, 6.5. So every single time in this table, the slope is 6.5. Okay, the change in y over the change in the x simplifies to that number. Now the other thing we need to find is our y-intercept. So again, the y-intercept is when x is 0. So every single time we increased by 1, now I'm decreasing. So when the x's do the same thing. We were increasing by 6.5, we're decreasing by 6.5. So the corresponding y value would also be 0. So my y-intercept, 0. So if I plug this in to y equals mx plus b, I'm replacing m with 6.5, keep the x, and I'm not going to write plus 0. Just going to leave it y equals 6.5x. Now the key thing of this problem said write it in function notation. Remember, function notation is that f of x instead of y. So the last step here, follow your directions completely. Replace y with f of x to say that this equation is f of x equals 6.5x. That's what we would use as our final answer. So our last example, write a linear function for the data in each table using function notation. So again, keyword there, function notation. So what we need to know our slope, m. We need our y-intercept, b. So remember, slope, y over x. So we first need to figure out how our y values are changing. So from 1 to 4, that's plus 3. From 4 to 7, that's plus 3. 7 to 10, that's plus 3. Again, I'm just writing 3 because I know that means positive. I'd actually put the minuses if it was a negative. So my change in y is 3 over my change in x. 1 to 2 is 1. 2 to 3 is 1. 3 to 4 is 1. So my change in x is 1. If we simplify that, that means the slope of our line is 3. Now, as for the y-intercept is when x is 0. So every single time x increased by 1, so now we're going back 1. And the y's, every single time it increased by 3. So now we just go back 3. So 1 minus 3, that's negative 2. So my b value is negative 2. So if we plug this in, y equals m, which is 3x, plus b, which is minus 2. But again, the direction said put it in function notation. So function notation does not use y. Instead, it uses f of x. So we just need to rewrite it so it says f of x equals 3x minus 2. So we fully follow the instructions. And that would be our final answer. So this concludes our lesson on being able to write the equation of a line given a table. If you have any questions, please ask Miss Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Miss Brooks.